Okay, so recording has started, and yeah, the video for the previous session, the video is already uploaded. It's online. Everybody should have got the email with the address. If you did not have the email, just write me and I'll send it to you. Yeah, and so we're pretty much ready to jump in and start. Let me quickly jump to my Node.camp folder. Where was that last time? Okay, so last time we finished with our little node module. We made a global module and published it in npm. It was counting, no, it was printing the contents of the home folder. Yeah. Okay, so now for the sake of this demo, what I will need to do, I'll probably write a little application just to show you how debugging works for Ever.js, something that is long enough to leave to show you the different aspects of debugging. So let's do something really trivial. So what I'm gonna do is let's have some variable called count, and each second I'll be just increasing that variable by 1 and printing it on the console. That will give me a little bit of context for debugging. So I'll have a state, some sort of a state to look at, right? So, and I'll be able pretty much to show the basic debug course. And I'll be printing out count plus plus. So let's see how that works. Node forever. Oh yeah, that's too fast because I forgot the second parameter. Each second. Yeah, it works. So there are several ways to work with Node.js debugging, and the first and the simplest way probably would be to go to something like WebStorm that has a proper integration with Node.js and knows the how to marry the UI with the debugger protocol, and will pretty much allow you to set all the breakpoints. By the way, if you open the WebStorm and you'll see the ugly things like that, that's probably because it didn't recognize that it is ECMAScript 2015, but you can quickly tell it to use ECMAScript 2015 syntax. Okay, so you can set breakpoints pretty much like in every other language and debug for Ever.js, right? Once it is connected to Node.js, it will hit the debugger, and in the interface of WebStorm, you can like set watches and check what is, oops, not const, what is the value of count right now. Yeah, it's 1. Go to the console, change the state of your application right from the console. Let's say the count will be 100, right? So this changes will be like applied straight away, and if you resume the debugging sessions, you'll see that the count should continue from the from 101. Why it's not continuing? Should be. Okay, so this is number 1 option. So you have all these things that you used to like in the other IDEs, like stepping over, stepping into, adding breakpoints, adding watches, everything that you might need during the debug session in WebStorm. So that's option number 1. And that's easy. Pretty much, I'm sure that the other IDEs will have it as well. Something like Eclipse plugins will definitely have some sort of debug integration. Okay, but now let's look at the other options in debugging. So we looked at IDE, which is the easiest and, well, the most typical way to debug the application. The second way to debug the application will be the node inspector. So let's say that you're a fan of Sublime or similar products, and you do not have these kind of plugins to integrate with the debugger, with V8 debugger, but you still want to debug your application, right? So you don't want to go back into the Stone Age and start writing like console log count is count or something like that. You don't want to do that. There is the option for you if you don't want to use IDE. This is called Node Inspector, right? To install Node Inspector, you just install it as the global package, node npm install -g Node Inspector. So let me show you really quickly how that will look like. npm install -g Node Inspector. So the idea behind Node Inspector is that since Node.js is written in V8, and V8 has its own debug protocol. It is just logical to marry that debug protocol with the debug tools from Chrome, for the Blink developer tools, right? So what it will do, it will start the little server that your Chrome browser can connect to, and then you will see all the similar debug interface that you can use in your Chrome developer tools, but instead of connected to the web page, it will be connected to the V8 running inside Node.js. So it is a bit lengthy installation, but hopefully maybe in a couple of seconds it will finish, and then I'll show you this debug option. It's really, really, really slow for some reason. It's actually painful. Yeah, thank you. So again, whenever you're installing the global module, you'll see at the beginning of the output, right, you'll see the scripts that this global module is adding to your directory that is in the past, right? So I now have two scripts, Node Inspector and Node Debug. So what I'll do, I'll say Node Debug and run forever.js, forever. I made a typo, but I'll live with it. And all of a sudden, browser opens. It's stopped in one of the lines in Node.js itself. I can open my application. I can make a breakpoint somewhere here. So you see that's my code. Let me make it slightly bigger. That's my code. I can run it. I can wait till the breakpoint will hit. I can explore it, and I can debug it just the way that I would debug the normal web page. But instead of web page, I'll have here my project with my files, with my breakpoints, and everything that I can do in Chrome developer tools I can do here. So this is a pretty nice way. This is one of the most favorite ways to debug Node.js applications, one of quite used ways to debug Node.js applications. So IDE or Node Inspector. And finally, this is the second way. The last way would be, let me release the, I'm just wondering, after releasing the interval, somehow it doesn't restore the set interval things, right? Don't know why. So the final thing will be to debug it with the built-in debugger, with the command line debugger, right? And well, frankly, you know, I haven't ever encountered the situation where I really need to start the command line debugger and connect to the process and start debugging it like from the command line. I can kind of imagine in some fictional scenario when you're like desperate and you're on a server and you need to debug the running Node.js process and you cannot debug it on your local machine, you cannot install anything, and it's like you're in a space, you don't have NPM, you don't have internet, and you need to debug the Node.js app. Well, in this case, you can use the built-in debugger. So how that works? You start Node, but notice before that I was starting node-debug. This is a command. This time I'm adding it as a parameter to Node.js. Node debug, and then forever.js. That should have been forever. And now this is my command line debugger. And in this command line debugger, I can pretty much do everything that I can do in the normal debugger, but I need to type a command for everything, right? So C will be like continue, right? So now it released my application. It's like jumping through the code. P will be pause. P is not defined. Should even B, break? No. Sorry, I'm not really using that too frequently, obviously, and yeah, it should be just the whole word pause to break it. Okay, so now I'm paused. I can add a breakpoint to the code and pretty much watch the expressions, evaluate what is it in the console, right? So I can write count, things like REPL. I need first to go to REPL, and then from this REPL loop, I can start interacting with the application. So I can see what is the, is it count? Well, I'm in the wrong context. I stopped in the wrong file. But anyway, this is how the command line debugger looks. Let me actually do it properly, right? So what I want to do, I want to set a breakpoint, and that goes SB. And in SB, I can say I want to set the breakpoint in forward.js line number 5. Yes. Now it hit the breakpoint in the proper line. Now from this part, I can say REPL, give me the console with the application, right? So go out of the debug commands, go to the actual console of the application. And now I should be able to see that what is the current count. I should be able to say that the count now going to be 100, and I want to explore the behavior of the application from that point on. I Control-C to back to the debug mode, release the breakpoint with C command, which stands for continue. And now it's hopefully gonna continue. Please. Should have continued. Yeah, sorry, it's not the greatest demo, but I think you got the idea. You have the command line tool in order to debug your Node.js application. And if you're like totally desperate and you really need to quickly debug something, you always have an option to do that, to debug your app. Oh, now it hit the breakpoint. So yeah, set interval is funny for debugging as far as I understood. Okay, so that's what you have. Hey, voice, anybody? Do you hear my? Oh, okay. So it's strange. So let me ask. I have pluses. Okay, so thank you. Looks like there was some glitch on your side. Thanks. Sorry, guys. So yeah, this is that's how you debug Node.js apps, and from the console you have to debug it really. I mean, you have to be really in desperate situation to do that. One more thing that worth mentioning, right? So you can debug the running. You can open the running Node.js application for a debugging, right? So usually you start, if you're debugging in your cozy environment and from your IDE, you usually start straight away the app for debugging, right? But it's not always the case, right? So Node.js supports opening the debug session for the running app, right? So what do you have to do to do that, right? You need to send this USR1 command to whatever the process ID of your current Node.js application, right? So you can, if you're in Linux environment, you can do pgrep and find your Node.js running instance and send that command to running instance. This way, it will trigger it will open for debugging. If you're on Windows, there is a couple of like a bit of obscure commands that you can execute. So firstly, you run from the command line task list. You will find the ID of the process that is Node.exe, or you can look it up in this like process manager thingy on Windows. And then you can call this little script. So you run Node.js itself, the other instance, and execute process debug process. And you pass the ID of the process. This way, you will be able to connect to the application that is runtime, so that is running right now, and you need to see how it behaves. So that's a real quick overview of how you debug Node.js. That's something that we should have done on the last session, but we didn't do that. Okay, so in the next several code examples, let me quickly close all the windows that I don't need anymore. What we will be doing, we will be working with the streams. But before we work with the streams, let me quickly remind you about one thing. I think I told about this object already. Process. Process is a global object in Node.js that is responsible for describing your current environment, right? The current process that you are executing. It has a whole bunch the whole bunch of useful things, useful properties on that object. So argv is the list of arguments that your application has been started with, and I think we used it on the last session. PID is the ID of the process, like current working directory, environment, like scheduling the execution for the next tick of the event loop. These kind of things are super useful. But also, what we will be more closely working with during this session is the streams that this process exposes or this process writes to. And as you probably know, all the programs, no matter what kind of program is that, they always will have the three streams: the std_in, std_out, and std_err. std_in stands for standard input. That's whatever the program will get on its input. std_out stands for the standard output. Whenever you're writing, for example, in console, right? Whenever you do console log, what happens in reality, it writes to the std_out underneath. So if you look up the sources in Node.js, you will see that implementation. And finally, std_error is the error stream. All kind of the notifications about the errors goes to that stream. And why there is the whole session that is devoted to the streams, why we structured this webinar in this way? Well, because streams is your abstraction that lets you connect to any kind of the data sources. No matter if you're writing or reading to the data source, no matter what is the exact transport that you're using for that data source, network or file, or it is HTTP, or it is just the stream of the program, you will use pretty much the same set of APIs. And once you master those APIs, once you understand how they work, then working with data going to be all of a sudden it's going to be easy, right? So let me give you a quick example. If you know how to take the file, take its contents, compress it to zip, and write to the other file, it's going to be super easy for you to do the same for the TCP/IP socket connection and whatever you got from that connection. Like really easy. So let's look at the streams, right? The whole abstraction is you've got the source of data, you can transform somehow that data, and then you write that data to the destination. So stream is your abstraction over those little building blocks, right? So, oopsie. Where's my presentation? Oh yeah, here it is. In Node.js, there are 4 types of streams that it recognizes that they have slightly different APIs. So readable stream is something that you can read from. So if you're opening the file and you get the stream from the file, that's going to be a readable stream. Then a writable stream, that is something that you can write to. So for example, if you're writing to the file, again, the same example, but whatever, it works. If you're writing to the file, that's going to be a writable stream. Then duplex stream, if you have something like a TCP/IP connection, right? You can read from that connection and you can write to that connection. That's going to be a duplex stream. And finally, the transform stream. So transform stream is a little bit interesting. It is both input and output in terms that it has the in and out, but it's not acting as a data source or the data destination. Rather, it changes something in the data. So, for example, as a transform stream, I can build the implementation of a stream, my custom implementation of a stream, that takes as the input the source of a JavaScript program, and it strips off all the comments from that program and gives the resulting characters to the downstream stream. I mean, to the stream that is connected. I think you understand what I mean. So these are the 4 types of the streams, and mostly you work with readable and writable. Transforms are slightly less common in your day-to-day Node.js life. If you're working with TCP/IP, you will have duplex streams, but again, that's for TCP/IP. For HTTP, you will have one readable stream that is a request and one writable stream that is a response. So now, without further ado, I don't want to show you slides. It's more fun to write that code and show how it works. By the way, if you have your IDE, your Node.js, and your environment opened, I will recommend you to just try to do the same as I. Write a couple of lines of code with streams because it's like super easy to do, and you'll immediately get the feeling of how those kind of programs work. Okay, let's save it. So what I'll do right now is I'll write probably the simplest possible program. I'll write the echo, not even an echo server, echo program. It will take everything from the input stream and it will write it back to the output stream. So how am I going to do that? A stream, first, first part of knowledge about the stream. It is the event emitter. So whenever there is something that is ready in the stream, some data in the stream, it will emit the event called data. So let's do that. Let's use it. So process. Remember, I'm getting the current std in of my current running Node.js app. Std in on. Right? It is an event listener. So I'm subscribing to event called data. And whenever I've got some data, I'll receive a chunk that just appeared on the stream. Right? What can I do with that chunk? I can say process std out. So this is a readable stream. I'm reading from it, and this is a writable stream. So I can write to it. Write chunk. So easy. Okay, now let's see how that works. Node streams. And now notice one thing. So Node.js is smart enough to notice that even though this program just has 3 lines of code, we are registering the event listener to the stream that is now open, so it will not close the program itself while the stream is still active. So I can start typing things like hello, hitting enter, and receiving hello back, hi, etc. So this program works, and this is an example of how you can super easily do the very basic piping of the streams, right? There is even easier way to do that I'll show in a couple of minutes. So that's the streams. And now let's do something more interesting, right? Because this example was kind of oversimplistic, maybe. Let's do something more interesting. So what I want to do, I want to write an application that will count the number of spaces in a file. So I can actually, as the file, as a sample file, I can use these same scripts because they have plenty of spaces. Okay, so what am I going to do? Firstly, since I need the file system access, I'll require fs. Awesome. Now in fs, I've got a bunch of useful methods that work with the streams. First is create read stream. So what it will do, it will open the given file for reading. And as the file, I'll just take the value from the arguments. So let's go process argv2, gonna be the first argument of the program. And the stream itself, I'll call it inp. Can't call it in because in is keyword, but inp is fine. So now, instead of using process std in on data, I'm going to write inp on data. So whenever there is some data on the input, I'm going to take the chunk of data and just to start with, I'm going to print that chunk back onto the std out. Actually, I can leave this line. And you're going to see one interesting effect that might be a bit unexpected. And I oftentimes see people who start working with streams is like, what the heck is happening here? So Node stream.js, and I'll write everything from main.js on the screen, right? So somehow it's smart enough to print. Oh yeah, sorry. That's actually interesting because I was expecting the data to be binary, not the text data. But what usually you should do when you're dealing with the input streams that are text, you should tell Node.js what is the encoding of the stream. Set encoding and UTF-8. Yep, that will make sure that you're reading the stream in the proper format, that you're not getting some sort of a garbage. Okay, so now you've got the chunks of data going to your stream. What you can do, well, let's count the spaces. Let space count, or just count 0. What should I do? Let's say chunk. I'll do it in a little bit suboptimal but lazy way. Split by nothing. That will give me the array of letters for each. And if the character that I receive is a spacebar, then count increases. Okay, so that's great. The only thing that this program is never printing the results somewhere, right? So how do I do that? And The input stream has another event called end. And this event, pretty much as expected, it will fire whenever there is nothing left in the stream to read, and that's your final point, the end point. So let's write the event listener, and whenever there is an end, I can say that I want to log total count spaces. Something like this. So now let's see if this program works. Node.js, total 13 spaces. So I pretty much believe that this value is true. I will not double check myself, but feel free to try it out for yourself. But you see this pattern, how it works, right? You subscribe for the events. Whenever there is a data that is coming to the stream, you can get the chunk of data, do something with that chunk, and listen to the other event called end. And this is your way to know that the stream is over. There is nothing else left in the stream. Okay, so one more important thing is in Node.js, streams have two different ways of working. Right now, what you saw, this is the first way of working. It is called a flowing mode, right? So why it is called flowing mode? Whenever there is a data, the data flows straight away into your program. So you are pretty much, it's not you who is in control of the stream, it's pretty much the stream that is controlling you. So whenever there is something, it just throws it into you and say, do something with it, do something with it. And you don't have a control, for example, for how many bytes you're actually reading, or do you still want to read or you don't. There is the other way to work with the stream that is called non-floating mode, right? So instead of listening, what is the chunk size? The chunk size is going to depend. This is a very good question from the chat. What is the chunk size? The chunk size will depend on the concrete stream, concrete environment, etc. So whatever is available on TCP/IP stream, whatever is the chunk of data that is being read from the file system, going to end up with a chunk. It's not predefined value. So in this case, because we are setting the encoding to UTF-8, it is the it is string, right? By default, it opens as the binary, right? And then you're reading the bytes, right? So, by the way, one good interesting thing. If you're reading the bytes from the text file, and this text file is multi-byte encoding, something like UTF-8, you should be careful when you're transforming from the bytes to the string, because what might happen is you might end up with the chunk that ends up right in the middle of the letter. So the letter might be encoded with, let's say, 2 bytes. You've read 1 byte in a chunk, and the second byte will come in the next chunk. So this is a perfectly possible scenario. And in this case, if you will manually transform from the byte stream to the string, you're going to have a problem. Okay, so how to do the same, but instead of just reacting on the events whenever there is the data on the stream, we want to read that data ourselves. That's super easy. So all that we have to change is the event that we're listening to, and in this case, we will listen to a readable event. So readable event is the event that is fired. Basically, stream is saying, you know what, I've got something for you. So if you want, you can read whatever you want. So you can read whatever number of bytes that you want to read, right? And if I have enough bytes, I'm going to give it back to you. So in this case, you have to get the chunk yourself. So chunk, you take input and you read from the input manually, right? The great thing about it, if you're designing some sort of a protocol for parsing a file, and you know for sure that the header of the file gonna be, let's say, 170 bytes. That's the predefined format of the file. With the read method, you can control how many bytes are you reading each time, right? And finish parsing the part of the stream once you finished the header, and then pass the same stream to the next function that assumes that stream stopped at the particular part, right? So you understand what I mean. With data, you're giving the chunk, you don't have the control over the size of the chunk. So stream can end up like 2 bytes or 3 bytes after the end of the header, and then you're going to have a little bit of a problem in the downstream functions. So with this way, you perfectly control what you are reading. One more thing, whenever there is the end of the stream, the chunk going to be null. And so we will test for null. And if it's null, we will just do nothing because we already have the end event. Or we could print the number of spaces. It will be the same. So this is the non-floating mode. Just for the sake of quick test, let's see that it gives exactly the same results. So just to summarize, you have two ways to read the data from the streams. Firstly, you can subscribe to the data events and wait till the data is available and you'll receive that data straight away. Second, you subscribe to a readable event, and if the stream is readable, that means that you can read something out of that stream with the help of read methods. These are respectively called non-flowing and flowing modes in Node.js. Okay, great. So let's do the quick overview of the streams. Yeah, by the way, the example applications are in the slide deck. I leave this code on the slides, but I don't want to show it from the slides. It's always more fun to write it. And but you'll have the reference point if you want to look how it works. One more great property of the streams is that they are meant to be piped, right? So what is a pipe? It's like in Next systems, right? So you've got a program called cat that can put the contents of the file to the standard output, but then what you can do, you can pipe that standard output to the program called grab, and out of that grab you can try to grab something. I don't know, there's no main word, but you can try to extract only the parts of this stream that contain a certain word. So this is pretty much the example of the pipe in the Linux systems, not only in Linux and Windows as well. And grep in this case will act like a transformer stream, right? The same can be done in Node.js quite easily. Remember the first program that we started with, right? So we took the standard input and everything that the user typed, we just send it to the standard output. We can do that easier. So what we can do is process std in pipe process std out. What that means, whenever there is data in process std in, it will be thrown straight away into process std out. The result will be exactly, thank you. Yep. The result is going to be exactly the same. Node stream. Whenever I'm typing something, this will be printed back to me. And this feature is becoming more powerful once you have more than one stream, once you have a little bit more interesting logic. So just to illustrate this example, we'll now write a simple application that compresses the file that it receives as the argument. So, and trust me, it is super easy to do with Node.js, and knowing the properties of the streams, it is super easy to do. The first thing that we will need, though, is zlib for gzip compression, and yeah, once I install it, there will be an error message, right, like this. If you do the same, don't worry too much. This error message is basically saying it tried to compile the native extensions, but it failed to do that. It will still work, maybe not as efficiently as it could with native extensions, but it will still work. So don't worry about this, all these red lines around. So what I'm going to do is what I need, firstly, the whole logic is I'll write the rest of the program later, right? I need the input stream, the input file. I need the transformer stream that will be, let's call it zipper. And I need to have the output file that will receive the zip stream. This is the whole idea. Once I get those three, what I can do, I can say input pipe zipper. So I pipe everything that is coming from the input gonna go and be zipped, and then the zipped version gonna be piped to output, right? And this is the whole logic. You take the input, you zip it, you send it to the output. So, and the rest, everything that is left to do is just to add the meat to this program, which is, again, a matter of very trivial code. require file system, and zlib will be like this. Awesome. Now input gonna be create read stream. We're reading from the file. That will be the first argument. Process args2. We're writing to the stream. That is also a file stream. Create write stream and process args3. Final zipper is something that zlib is providing us. So zlib create gzip will create that transformer stream that can compress the stuff. And that's it. So I just wrote, 8 lines of code minus 2, 6 lines of code to take the file from input and send it zipped to the output. So let's see if that works. Let's take main.js and send it to something like main zip. Whoa, cannot read property to, argv. Yep, that's gonna work. Okay, so we zipped it. Let's open our folder, see what's inside. So here's our newly created main zip, and you can pretty much look at it and see that this is unzipped our same main.js file that as we used to do. So just that simple. So this is the grand design idea of the Node.js streams. They are completely interchangeable, at least they should be designed to be completely interchangeable, and they implement either the transport logic, like sending things over the network, or transformation logic, like zipping or stripping the comments out of source code, or you can think about the other applications as well. And and if you master them, you can pretty much work with any kind of transport, any kind of environment. And in a couple of minutes, we'll see how that works on the example of network applications. So we started with file system. We played a little bit with the streams of the FS. And now, just changing a few lines of code, you will see that the network programming is easy once you understand the basic concept. Okay, so let's just recap before we jump to the network. Let's just recap what we did. We know how to count spaces. We know how to pipe streams. There is a couple of slides with the APIs, right? So there is a list of events for readable streams and writable streams. They will be pretty much present on any readable and writable stream, right? So readable is I have more data. Data is here's your data, and I will not ever send you any more data. Close, I've been closed. Error, there is a problem. Read, you can pass the optional size parameter. You can set the encoding. You can pause, resume, pipe, unpipe. Unshift is interesting. It is an interesting function. It basically allows you to send part of the data back to the stream. So if by accident you have, or if you're listening to the data events and it turned out that you've read too much, then you can send some data back to the stream so that the next function that's going to work with that stream, next part of your program that's going to work with that stream, it will start from the right place, right? And the similar, very symmetric writable API. So drain is an interesting event. It basically will tell you when the writable stream is ready to receive more data. Finish, pipe, unpipe, error, pretty much trivial and self-explanatory events that you can use to work with writable streams and make sure that they are nicely written. So finally, by default, the streams will be binary. Make sure to set encoding if you need to have the text stream. There is one other type of the stream that is called object stream. What you can do is, instead of sending over the bytes or sending over the strings, you can send with this absolutely the same logic, you can pass JavaScript objects around, right? We will not look into too much details about how to actually implement that in practice. It might be useful if you're designing your application over the idea of the streaming. You can pretty much stream like the events, the stream of events. A great example of the encapsulation of how you got these events or where you got them from, right? So just quickly check what else we've got on stream. Yeah, the streams are starting in non-flowing mode, right? So by default, you're gonna subscribe on the readable event. If you subscribe on data or you call pause or resume, it will start feeding you with data, right? It's just like a start function. Think about it this way. And yeah, duplex and transform, we saw that already, and we saw how to gzip things. And here's some code for your reference. Once again, I will send the email with the link to the presentation, so you will be able to quickly remember how to do that. Okay, so now the exciting part, networking, and I hope you've got Telnet, because very soon I will invite you to try the server that I'm about to write. If you're on Windows, then download PuTTY or PuTTYTel. The default Windows Telnet is acting a bit funny. It is sending each character one by one instead of sending each line. Again, it can be fixed on the server side, but I won't write the production code. So download PuTTY if you want to play and say something in the live to everybody else, because you should be able to see me in your network. Let me quickly see what's my IP. What's my internal IP? Here it is. This should be my IP, right? Write it down somewhere. So let's create the new file called Node.js. So you can try to ping me and see if you will see me. And what I will start doing is this time, just using the same knowledge about the streams that I had before, I'm going to start writing the TCP/IP client-server chat application, which is, again, the basics for all kind of an exchange application that you might encounter. So let's start from getting the NAT module. NAT is for TCP/IP. Actually, I think it's also for UDP, but again, out of the scope for this webinar. Require NAT. So now I will create server, and create server is a function that accepts another function, a callback that is executed each time when somebody is connected, right? And whenever somebody is connected, we will receive his socket. This is our gateway to that particular connected client, right? And if I just say at this point that socket is a duplex stream, and duplex stream that is readable and writable at the same time, this should be enough for you guys to understand and start working with this socket, because you already know how to read from the stream, how to write to the stream, how to change stuff with the stream, and you know pretty much everything. So let's try to write an application and see how easy it will go. So I will listen to 7171. If I'm not passing the host name or IP, then it will try to bind to every available interface, which suits me. Not very secure, but don't hack me, please, guys. And here, whenever somebody is connected, all right, I got a new client. Okay, so very basic TCP/IP thing, a stub. So now, before I continue, I want to show you another great utility that I very, very frequently use when I develop Node.js application. This utility is called NodeMon, and again, it is installed as global npm module, so npm install -g NodeMon. I will not run it right now because I just saw that my internet is not that great and I have it already installed. I just don't want to keep you guys waiting too long. But what NodeMon does, it will start monitoring the folder that you're in right now. Whenever there is a single file that is changed, it will reload the application. So if you're writing something like a server, and after you finish writing the changes to the code, you always need to Alt-Tab and restart the server, then you're wasting time. So with NodeMon, what you can do, you can write NodeMon net. So net is the name of my script, Node.js. It will look at this Node.js. Now look at the following. I'm changing something in the file, I'm saving, ding, it's restarted, right? So Super easy. So this way I can focus on writing my logic here, and my running server will always be up to date, kind of. So it will be restarting all the time. Of course, it's not always applicable. So if on restart you're doing something funky or long-running operation, like, I don't know, connecting to some remote database and downloading that megabytes of that data, might not be a good option. But anyway, let's go. Oh yeah, somebody is super fast. Hello. So as far as I see, my my client, my server works, and I see connected users. Just for the sake of completeness of that demo, let's try to connect. I'll show how to connect from your own host. So telnet, and you say localhost, and 7171 should be my port number, and I hit enter. I'm connecting. I'm the new client, and I can create as well. Okay, awesome. So my basic server works. Now let's do something more interesting. So what I want to do is, the next thing, I want to write the echo server. Sorry, you probably just got the bunch of errors saying the basically server terminated the connection. Yeah. So what I want to do is to write the echo server. How to do that? Well, firstly, I just want to make sure I'm receiving text. Set encoding. This is text protocol. So UTF-8 is my encoding. Now I subscribe to readable event. Readable, whenever the socket is readable, whenever there is something in that socket, I want to sock read it. And this is going to be my chunk. And the basic thing to do is just to say, well, I'll write it back. Chunk. Awesome. Now, the only thing is that if somebody will be disconnected, so if you close the connection from your side, this will come as null. So sock read will return null. So I need to protect myself from that. And save chunk is null. I didn't want to do anything. I'll just return. And to be super, super nice, I will also subscribe to another event called end. And this will tell me that somebody has been disconnected, right? By the way, from this socket object, you can tell the remote address and the remote socket, the client socket that has been opened. But we don't want to do that. Disconnected. Okay, so that's my second version of the server. Let's run it and test it. So I can now connect to localhost. Got a new client. I can say hello and receive hello back. So if you type something, you will receive back whatever you have typed. If you're in Windows and you're using PowerShell default telnet exe, you will receive character by character. This is a known thing, and frankly, I don't know how to fix it. Looks as that Stack Overflow also doesn't know how to do that. So yeah, so we've got the client working, and just to finish the little example that we're doing, let's make it a little bit more fun. Before we jump to the coffee break, let's make an actual kind of chat, right? So that instead of sending to just one person, we're gonna send it to everyone, right? Const clients. So whenever there is a client, I will save the socket. Clients push socket. And instead of writing just to one socket, what I will do, I will clients for each client, I will write that message to everybody. So I will echo it back to the original sender, and I will send it to everyone else, right? But now again, I have to be careful. Oh, sorry, I just dropped a bunch of you guys. I have to be careful at this point, because if I'm just keeping the collection of opened connections, right, and you close that connection, the stream itself will be closed. And if after you are disconnected, if I will try to write something to you, I will basically get an exception. My application will crash. I don't want to crash my application, so I have to take care of this special case. If you're disconnected, I want to make sure that you're removed from this list, right? So I'll put it here. Index will be the client's index of the socket that has been disconnected. So I'm in end event listener, so I can find the index of the disconnected socket, and I can say client's splice index. As far as I remember, that's the way to do it. So now let's give it a test. If it works, then we can have a nice coffee break, and I'll leave screen and we can see if the chat works. So I get a new client, hello, writing to the client. I'm getting hello back, so the basic functionality works. Oh yeah, somebody's probably typing something in Russian or in Chinese or in some other language that is not supported by my terminal. And yeah, so basically I don't even need to say if it is working or not, because I see it already. And I'm glad to see you all guys in the Telnet chat that we've got. So again, just for the sake of completeness of that demo, I want another client, and I want to kill that client and make sure that my chat doesn't crash afterwards. Yeah, somebody disconnected. Thanks. That's a good test case. Telnet localhost 7171. I'm connecting. Now I'm disconnecting straight away, and I should be able to type hello and get my hello back. So yeah, that's the very basic TCP/IP chat application with Telnet. Just following the same principle, you can write the TCP/IP client on Node.js, but instead of opening the server socket, you're going to connect to the server socket from the client. But at the end of the day, you also will get from the client side TCP/IP of TCP/IP connection, you will still have the object socket, right? That will be a duplex stream that you can listen to whatever server sends to you, and you can write something to the server. So on this point, let's do a really quick 10 minutes coffee, cigarette, email break. Yeah, I'll rehydrate, and then we'll continue with Node.js. We're going to talk a little bit more about the web part of Node.js, and that's the fancy part, because that's what everybody's doing with Node.js Web. Okay, see you in 10 minutes, guys. And I hope you're all still here because we are continuing with Node.js and we're back from the break. So let's do some more fun stuff. So Node.js is oftentimes used for HTTP, and in the next section of this webinar, we're gonna talk about HTTP and how that thing works. By the way, again, just to show you a little bit on the slides before I jump out of this subject completely, let me check. Guys, do you hear me good enough? Is the sound okay? Yeah, looks like okay. Okay, great. So I just give you a quick run through the slides. Again, this is the basics of that code that I have written. Doesn't the slides, they do not guide you through the whole chat application, and yeah, but you can find the client-side code for TCP/IP networking. That, again, I will not stop on that too much because it will be just the repeating of what we already know, but you can find those on slides and try to experiment when you have a little bit of time to do something interesting with Node.js. Okay, so the next thing that we will explore is HTTP. And just to set the ground, you all know that HTTP is request response based protocol. So whenever you're working with HTTP, you cannot just randomly start reading from the request and writing back the response. It's just not possible. So in HTTP, it's all sequential. So you first have to read everything from the request, and then you can start responding to that request, right? So in HTTP world, you will not have a single duplex stream like the socket. You will rather have two streams that are one-sided. One is readable stream, which is a request. That's the place where you read what exactly client wants from you. And the second stream is a response. It's a writable stream, and you can write something to the clients, right? So this is an example of a client, but I'll probably, again, for the sake of saving some time for the fun stuff, I want to skip it. Oh, let me shut down the server, and I'll create another file called http.js. Okay, awesome. So where I start from, I require HTTP. Again, one of the core modules of Node.js. Don't need anything to start working with HTTP. And just like before, just like with TCP/IP, HTTP has the function called create server. But this time, obviously, this function will be executed. This callback will be executed for each request and response. So typically, this is how you name the request and response objects, right? And let's put that HTTP server to port something like 8080. And what it will do, so this HTTP server will be super simple, and I will be just writing hello worlds back to the client. So because res is the writable stream, I can just do the following. So that's my whole application. It is, again, it is not the best HTTP application. I'm not sending any headers back. I'm not setting some mandatory headers like content type will probably be a good idea. But let's just start from this thing and see if this works or not. So again, I'm starting that with nodemon because I want this little HTTP server to be restarted over and over again whenever I'm changing the application. And yes. Okay, so I have my server. Let me close the unused windows. Let's test if that server works. Curl is my tool of choice whenever I need to test something from the command line. And localhost 8080, as far as I remember. Yeah, it gives me back the result. Again, this is just a stream. You know how stream works. This is a writable stream, so you can do things with this stream. These modules, HTTPnet, were written with streams, right? So they provide you the streams. So they use streams internally, and they provide you the access to the streams. That's right. So let's make this a little bit more HTTP conformant example, and let's add a little bit more details for the client. So response is the writable stream, but it is not just writable stream. It is also HTTP writable stream. So it has some extra methods that are specific to HTTP. Obviously, these methods will not be present in any other streams, but in HTTP they are. Things like write head. Write head is you return the header part of the response. So this will be my response code. It stands for OK. And I also write a header. Content type will be something like text plain. Again, don't think that you need to do that all the time, every time that you're writing HTTP server. I just want to show you guys how that works in the internally. And somebody is trying to destroy the wall behind me, probably. Guys, if you will hear the noise from the heavy construction instruments, just let me know. I'll kick somebody's face. So this is not the code that you will need to write each and every time that you write the server, because there are many frameworks that really optimize this whole process and make it significantly better. But in order to understand how that works internally, let's just do that once, because it's kind of nice. Okay, so we can do localhost 8080, receive. Again, if you want the verbose output from the curl, you can get it, and you'll get the status, and you can get the content type. So that's what our server is getting. So now a simple task for you. Just, you shouldn't really be writing code, but think a little bit. Let's say I have index.html in the same folder, right? And I want to send the content of index.html back to the client. What should I actually do? How would you write that code? Just give me 1 second, think about this task, and I'll try to ask to stop doing the construction workaround, because this noise is bugging a little bit. Okay, I hope that for you guys it is not super audible, and yeah, we should fix it soon. I mean, the construction noise. So yeah, that's exactly what you do. The responses in chat are exactly right. So let's just try to write this code together. So we need the file system to read from the file, require fs. We need to, whenever we're requesting, obviously it is not the super optimal server because it's not caching anything and doing stuff, so it will be reading each and every time. It will be reading the whole contents of the file. So what we can do is we can say that the input stream is the fs create read stream. We're creating the read stream to read the file that is index.html, and then what we do is just we in pipe res. That's all. So basically, this will make sure that all the data that was in the input are gonna end up in the output, and that's pretty much what we want to do. So now let's add the dummy index.html file and see how that works. Touch index.html, and let's echo something there. What's up with my typing? Echo I am index here. Go to index.html, and now we can restart our server and see if it will send us, oh, ouch, res is not defined, res, fs, sorry, file system. Good thing about the NodeMon, it restarted the server, so I don't have to kill application or restart it manually. It just works. So I am index. See, so I received back the contents of the file, and the same way you can do pretty much everything. You can send images, you can send generated images, and you can do all kind of other stuff. Client-side connections. Again, I will jump to the slide for the sake of the client-side code, because after you wrote the server-side code, it's kind of super easy to understand how client-side code works. Just, again, you are doing HTTP request, right? And what you get at the end is two objects. You've got request, that is a writable stream. You can start writing to request. If it is post, for example, everything that you write is going to end up in body, obviously. And you register a listener, which is a response. So whenever you're getting the response from the server, after you finished writing, you can get the results of that response. You can, for example, stream it to file to save if you're working on the web scraper, you can save the contents of the response to the files, for example. So HTTP is super simple, but you can probably imagine that writing something, at least something meaningful, starting from such low-level APIs, it will be like a problem. It will take lots of time. And Node.js itself is trying to be minimalistic. It doesn't have too much in its core. And the whole infrastructure of Node.js and JavaScript modules that you have in NPM, it gives you all the additional capabilities that you can work with. Again, a quick run through the slides. You have all the same code that we have just written, maybe a little bit shorter versions, but you should be able to get around with this code. So the next thing that I want to show you in this session is the first framework that we will use. It's called Express.js. It is quite small. It is several hundred lines of code, but again, it is super useful, and it is the part of so many Node.js HTTP server applications. So whenever you're building the REST service, or you're building the simple web app, simple blog, whatever, you're prototyping something for the client, chances are you will use Express.js. So what is so good in Express.js? Before we start writing the actual code, I want to talk a little bit about its infrastructure. Express.js is Sinatra-inspired framework. So Sinatra, it's probably coming from the, if I'm not mistaken, it's coming from the Ruby land. So Sinatra-inspired framework that breaks down the whole functionality of your web application, whatever it is, logic, serving, static files, or logging, or implementing security. It splits up it into the set of middlewares. So a middleware is pretty much like a module of the application that is responsible for something. And then the rule is super simple. The middleware, it is, from design patterns world, it is a chain of responsibility. So the middleware can do one of two things. It can either decide that it will handle the whole request itself, and then the whole chain is ended on this middleware, or it can do something and then pass the control to the downstream middlewares. So here on the example, you have like two requests, right? So let's just, for the sake of example, say that the first one is the logging middleware that just writes to the log who has accessed the server. The second one will be the security middleware, and the third one will be the logic middleware that serves the actual thing if the client is authorized. So for example, if this is the first request and the client is authorized, it will be first logged, then the security will be checked, and then, since the security check went okay, the third middleware will send the response some secret value that only authorized users can see. The second example, the workflow to the right, might be the unauthorized user, right? So the first middleware logs that somebody is trying to access us. The second middleware checks the security and says like, oops, no, this user should not be looking at this resource. And it will give the something like 403 response to the user saying, sorry, buddy, you're not authorized to view that. And it will not give the control downstream to the other middleware. So that's the whole idea of Express.js. You break down your application in this set of layers, and each layer is pretty much distributed as a node module, and the great thing, they are interchangeable, right? So logging should not be dependent on the sessions, on authentication or authorization, and this way it looks like Lego, like a bunch of bricks that you can combine together to achieve the application logic that you're looking that you try to achieve, right? So let me show you a little bit of a code example. Okay, so how to do that, how to write our Express application. Let's probably create the new file. Just not mess around with HTTP. Oops, close it. So let's create the file. I'll call it exp.js, standing for Express. And the first thing that I need to do is obviously to install Express. So npm install. And remember, if you are working with the application, chances are you will save your dependency in package.json. It's like 99.9 times percent of times you have to do that. So make sure to add it save flag, right? This way npm will write down the version of the dependency that it will use. And I want to download Express. Okay, so I've got Express, enter. We will need significantly more modules. So Express is very modularized. The core is super small. It's pretty much just load the modules and make sure that the middleware are executed in the right order, while the actual middlewares, each of them are distributed as a separate module, pretty much. So let's start writing our app. So firstly, let's get Express const. First, let's get HTTP, because we will need it. Require HTTP. Express will require Express. And now what we will need to do, we will need to have server. Create server. And now remember, in order to do the server, right, we need to put something here. So here should be some sort of event listener for the HTTP server. Well, that's exactly what Express is giving you when you invoke it, right? So const app equals Express, right? So you create the new application, and the app, what it is, it's not an object, it's a function. It's exactly the same function as we were writing before in here, right? Remember, request response. But instead of just implementing this simple bit of logic, it has all this whole full flow of the middlewares inside, right? By default, there will be no middlewares at all, and this application will do nothing, but you understand the logic. App is a function that is responsible for handling requests and responses, right? Okay, server listen. Let's listen to 8080. And whenever we're ready, let's listening to 8080, something like this. So, okay, so this is my minimalistic app. I'll just start it with nodemon exp. Okay, so it's listening, it will do nothing. So if I call this server, it will not respond with anything. So now the next thing that we will do is we'll start adding those middlewares. So what is a middleware? A middleware is a very simple function that just has 3 arguments, which is request, response, and next. So what are they? Let me show you. App use. App use means I want to register a new middleware. So I want to register a single middleware, and the signature for that is request, response, and next. And in this middleware, I'm gonna say response, and I'll just copy actually response. Remember how was it properly stated? Okay, send hi there. So let's try that out. Curl localhost 8080 giving me hi there. Awesome. So this is my basic middleware. So let's say that I want to introduce some sort of a, I don't know, lottery. So with the probability of 30% or 50%, you will be treated as the unauthorized user. So obviously you can write the proper logic instead. So what you can do is you just add another middleware, use and write another function saying, you know what, before executing this guy, I want to execute something else. So this function again, request, response, next, same signature. What you can do here, if mass random more than 0.5, so we'll just say that we send boo, not authorized. And in the other case, what we're going to do, we don't know what to do in the other case, right? This middleware, this little function is only responsible, let's say, for security. This is my random security system. So in the other case, what we're going to do, we will need to call the upcoming middleware. So we call next. If we do not call next, then the request processing ends here, it stops. If we do call next, then the next middleware has a chance to work. And in this case, it will print hi there. So now let's see if that works. Boo, not authorized, hi there. Boo, not authorized, hi there. I have a fantastic mass random. Oh yeah, finally, two in the row, because I was thinking it's like 1, 2, 1, 2, 1, 2. What's happening with mass random? So here is the example of how to organize this logic. See, and basically what you can do, you can extract all these little functions into their separate files. You can extract them into the separate Node.js modules, and you can make sure that your application is super modular, and you can support each module, test each module separately from the others, right? So this is the core idea of Express.js, and obviously again, there is a bunch of middlewares that we'll look at in just a couple of minutes that help you to do typical tasks that you might encounter during your work with the application. Okay, so one important thing is error handling. So whenever you work with a framework, my advice is figure out how to handle errors. It's like the second thing after hello world that you would usually do. In Express, it is, again, it's super simple. If you register a middleware that accepts 4 arguments, this is treated as error handling middleware. So it will only happen, it will only be called if there is an error, if there was an exception showing in one of these guys. So let's say res send, whoops, we got error. And to simulate the error, we'll do something stupid here. Say foo bar equals 5. So obviously this will cause an error because foo is undefined, foo bar is undefined. You cannot assign there anything. So let's see if our middleware will indeed work. So hi there, and we've got an error. Why res send isn't a function? Okay, we'll deal with that later. It should be a function. Okay, so now this is the basic of Express, and now let's try to build something more interesting. Let's build an actual app with the help of Express. So web app. I'll shut down the server. So what I'll do, I'll create a folder called public. This will be the place for all our HTML, CSS, and all kind of this thing. So I'll move my index HTML to public, and here's my structure. Basically, out of all the application, we will use exp.js. It's our main entry file for Express, and we will also use public folder. That will be the our place for HTML and CSS files. And our goal is to build a simple app, a very typical web app that like you do all the time. Let's say that we are serving the statics at the same time we're providing some sort of a REST service back to the clients. Yeah, potentially you're right. I see the comment. Maybe error is the first argument. Let's just give it a try. Again. Usually you don't write that by hand. You don't write the error middleware by hand. You usually use one of the modules, you plug it in, and it just reports it, logs it, or sends you an email with the details of the error. So node-mon, Express.js, and yeah, thank you. Awesome. Thank you. That's a great suggestion. Thank you very much. Okay, yeah. So I mistyped the order of the arguments in the error handler. Thanks. So let's try to build our small application with a small REST service. So where shall we start with? Let's start first from serving the static file. And again, you will not write the code yourself to read the file and to serve it back to the client. There is a middleware that does it already. So how we usually do that, use Express static. Express static is the function that creates that middleware. So you pass as the parameter what you want to store to serve as the middleware. And here we'll use an interesting variable, global variable that is available for every module, which is a dir name. Dir name will be the name of the directory that you started the application. Sorry, that the script that the main script resides in, and we'll take this dir name, add public to it, right? And this will point to our public directory, right? So again, please don't do that, right? So you obviously understand what is the drawback of this kind of scenario, right? If you start serving everything from your project, you're going to serve the server-side files as well, and everybody who's having the access to your folder will be able to read the details of your server. That's not always what you want to do, especially from the perspective of security. You might give bold hints about possible weaknesses of your application. So we're serving everything from the subfolder public, nice controlled sandbox. Only what we allow to be there going to be served to the clients. Okay, let's see if that works. So listening to 8080, and I'll actually open that in the browser. Localhost 8080 and index.html. Oh, yeah, that's why. Sorry, I'm losing a bit of attention a little bit. So instead of using the template string from ECMAScript 2015, I just used the regular string. That's why I didn't resolve the folder. And obviously I didn't get any. Yeah, I'm index. Here's my index, and that should work. Just / should work too. Okay, so now I know how to serve static, right? So the next thing to do is we've got. So let's say that here in public folder, we've got some AngularJS application. There's a bunch of client-side JavaScript. There's a bunch of client-side CSS, and the application is written. What you usually also want to do is to provide a small REST, not small, but depends, a REST service for this application to get data from. So single-page web apps that people like so much usually work with the REST services. So what we're going to do to provide that service? Let's start from the simple things, right? Let's say we want to serve the list of the books to the client. How do we do that? So I'll quickly mock some data to make it a little bit more interesting. List gonna be the store will be the list of books. Let's say each book will have ID and title, and I will just add one book, the time machine. That's going to be a title, ID 1, and title, the time machine. This will be the collection of my books. Actually, let's make 2 books because one is not quite clear. Let's make 2 books, and Hobbit. Okay, so now I have 2 books in my collection. Now let's see how to start writing a simple REST service with this kind of a little setup. So what we want to do, we want to say that whenever user will enter something like API/books, he will receive this list. He will receive it as JSON. So we will work with the JSON-based REST service. Okay, so app, and here we put the HTTP verb app get. That means that this route will, this middleware will only react on get requests. Then we put the route that we want to use, that we want to match. So we want to match the route called books. Okay, and now we can register our middleware request and response. It will not, so once we hit this route, it will not call any further middlewares, right? So we do not need the third parameter next because we are not going to use it anyway. It will be the end of the journey. If you're hitting the books, then you will receive the list of the books. And in order to give it back, you can write res JSON and just put store. That's it. So just that simple. Where this thingy came from. This is not a standard behavior that is available in a stream. This is not even the standard behavior that is available in the HTTP module. Rather, this is something that Express.js itself adds in order to help you to do this very typical task. Because indeed, sending JSON over the wire over HTTP, it's something that is super trivial and super common to do. So there is already a helper method that does 2 things. Firstly, it sets the proper headers, right, like content type, and secondly, it serializes, it makes the string out of JSON and sends that string over to the stream. Okay, so now let's see if that works. So here's my, actually I can minimize this thing and localhost 8080 books. Actually, I wanted it to be API books, but I'll fix it in a second. And here's my books, right? I've got the list of the items that I have in my collection, and I'm good to go. So that's one thing. What are the other REST methods that you usually add, right? Usually it is a good idea to be able to add something to the collection. So let's write app post, right? And here this, actually I want to fix this one here. I want to make it API books to keep myself tidy straight away. So API books, we're writing the post for the API books. And what post method does, it adds the new item to the collection. So you're posting something new here, right? So in order to support the IDs, I need to add something like max ID. In my example, going to be 2. Really ugly hard code, but again, for the sake of the example, this will just work. So, and now we have an interesting thing here. So the client will send us the JSON of the object encoded as JSON, right? And we will need to parse it somehow. And obviously, the first thing that you can do, you can just read everything from the request, take the request body, and parse it yourself. However, there is already an existing middleware that does it for you. So if it will detect that the content type of the request is JSON, then it will parse the JSON, and request body going to be a nice object that you can work with. How do you add this middleware? So see, we now got a bunch of middlewares added. Those middlewares that are used with use will react on any kind of any verb, any HTTP verb, and on any route. Those are with app get, app post will only react on the appropriate HTTP verb, and will only be served if you hit this, if the pulse is matched with the URL. Okay, so how do we add another middleware? Again, the very typical scenario for Express. You go to the folder and you go npm install save body parser. Okay, so body parser is the middleware. We can get it here, const body parser. It can do two things. It can parse multiparts and it can parse JSON. Since our application is a nice REST service, we do not want multiparts, we just want JSON. So what we will do is somewhere above from the books, right? And it makes the difference. You need to put the middleware in the correct order. Let me clash this thingy and this thingy and this thing. Clashing is not perfect. Okay, so you need to make sure that the middleware are put in the correct order. Why? Because if they are not in correct order, then by the time that Express will try to execute the post on the books, the body might not have been parsed yet, right? So middleware that you use first will be executed actually first. So the order makes a difference. So let's do that somewhere here. Oops. App use body parser JSON will create us a middleware that parses JSON. Okay, so let's see if that works. Node1 exp, and I've got a typo. Require body parser. Yep, now it works. Okay, so now let's see if this will help, or how this will help, because I'm pretty sure that it will help at the end of the day. So what we're gonna do is we will now express this middleware that we downloaded. It will replace request body with the parsed JSON. Okay, so let's say what we want to do is let's take it as our item. Let's add this item an ID. And let's push this item to store. Again, this is the way to very quickly draft the REST service for your application. Really just actual useful code is only like 10 lines and you have something working. So let me remember how to send the headers with curl. As far as I remember, -h. Content type. And the body will be very simple JSON. Oh yeah, by the way, it will not really work because we're storing the item, but we're not giving anything back. So let's send the added item back to the client. Something like this will be better. Oh yeah. And the URL API books. Assignment to constant variable. Where am I? Assignment to the constant variable. Oh yeah. That's why I like NodeMon, right? So I quickly fixed one bug. I don't even have to look in the other console and restart it. So yeah, awesome. It worked from the first time. Actually, I'm I'm even surprised that I remembered all the parameters and never mistyped the case. So yeah, so here we're posting the JSON to the collection, right? Body parser, this middleware, it is extracting the JSON from the stream, from the body, from the request, and it is replacing in the rec object, in the request object, it is replacing the body parameter with whatever it has parsed, right? So all the downstream middlewares, all these guys will have the access to the body as an object already, right? And again, one important thing to take away from this part is that the order matters. So for example, there is two middlewares that usually works and they usually work together. There's one middleware called session that allows you to save some sort of information, associate something with the user. And the other one is called the cookies, right? Cookie parser. So most usual way to organize your session is through the cookies, right? So you have the session cookie. So if you put your cookie middleware below the session middleware, session will just not know the cookie, the ID of the session, right? So it will not be able to work. So pay attention, and well, it's going to be quite easy to write the write your REST services afterwards. Okay, so now let's finish this example. I will not implement too many the whole spectrum of the REST methods, right? I just will show you how to create details of a single book, because it will show how to match URL parameters. And that's going to be, I think that's going to be it. We will run out of time for this session. Actually, we're doing quite good. Usually Express goes to the next day, but we're doing quite good. Okay, so let's do that. So now we want to have a URL for a concrete book. Obviously, you cannot you cannot create a middleware for each and every book that you might have in collection. So that's why you've got the URLs with the wildcards, with the parameters, sorry. API books. ID gonna match the everything that goes after books with the property ID. Request response. Now, how do you extract this ID from the middleware? Again, this whole thing is on the slides. You can not try to write down or remember by heart how this is done. This whole reference is on the slides, and you should be perfectly able to write your own little REST service with Node.js, and maybe instead of using the array, use MongoDB. It's also quite easy with, yeah, the API is quite trivial. So let's do that. So the ID is const ID is request params ID, and because by default it's going to be string, I will just make it a number. Could write number here instead of plus, but plus also works. And I can write some logic here to find the book by ID and return it, but just for the sake of the demo, I will actually, let's write it properly. There's not too much time to write. Find index that item ID is the same as the ID that we received. And if we have found this index, then we can return back the item. Something like this. Obviously, you have to double check here. If you're writing even the mock service, it's going to be a good idea to check for -1 if you haven't found the item, and send the status for 404 not found. Okay, so let's see if that works. So we should be able to retrieve an API books number 1. Cannot get. Awesome. Why? Did it restart? Let me quickly. Oh yeah, thank you. Thanks. I'm using wrong method. Yeah. So this should be better now. Yeah, awesome. Time machine, Hobbit, everything there. So this is the way that you can you can parameterize your URLs, right? By the way, if you want to have something like the query parameters, right? So if you want to have like foo equals bar, this kind of thing, you can also access, obviously, you can access that with request query. So console log request query foo will print you the value of foo if I'm lucky enough. Yeah, here it is, bar printed. So this is the way that you organize your REST API. Obviously, if you know how to process GET, if you know how to parse and find the parameters, if you know how to send back JSON, that's pretty much everything that you need to know to build in an API, right? So delete is like it's like GET. It doesn't have body. It just removes the item from the collection. Put and patch are also quite easy to do, but again, you will need to implement it in a similar manner. So what does plus mean in plus request params ID? So the request params ID by default it's matched as a string. So this thingy is the type of the thing will be string, right? So I could quickly show you Node. So type of 1 is string, type of +1 is number. So it is converting the thing to the number, because otherwise it will not match in the find index function. So awesome. That's we still have like a couple minutes left to talk about Express, and I think I'm gonna finalize this subject in this session. And in the next session, by the way, our first subject will be one of my favorite, which is Socket.io. I'll show you how to quickly, like in 20 minutes maybe, write the real-time chat application in Node.js and Socket.io, and that works with web, not just through TCP/IP and Telnet, and it's gonna be fun. Okay, so the last thing that I want to do to show you is to show how to create a router, right? So this whole thing, we can take away this logic, this part that is responsible for API, and move it to the separate entity, to the separate file in the best case, right? Because usually you don't want to have this whole main file with everything, application logic mixed together with some infrastructure thing like serving publics, like starting the server, everything is mixed in one file. What you usually want to do is to be able to distribute the parts of your application logic, and how you do that is with the help of the router. So what you do, you create a router. Router is Express router. I think it's uppercase router. Let me just see if I have any errors. Yeah, okay, so I don't have errors, and I typed router properly. So what you can now do is say router, wrote, and here you wrote API books, and then for this route, you just for this endpoint, you basically start adding methods. Get, you put that logic here, and goes post, put that logic here, and it is now all saved in a single object, right? So this object belongs to the object. It's not dependent on the application itself, right? So the same you can do with root API books ID, right? Router wrote API books ID, and well, I just have get here, so I'll register it on this route. So you see the difference. Instead of registering everything on the application itself, I'm registering it on the separate object called router, right? The benefit of it, let me first check that it works. App use router. Router will create your middleware. App crashed. Oh yeah, semicolon. Making too much typos. I need another portion of coffee will definitely help. So, crashing again. What's up? Router, oh yeah, you don't need the, you set the root, so you don't need to duplicate that, obviously, sorry. Confusing the syntax a bit. Okay, so basically you set up the root and you say, for this root, get gonna be this, post will be this, for this root, get will be this. And it all is registered on the router object, and you can then use this router object on your application. So if this thing, yeah, it works finally, and let me just check. Some reason it's not hitting the books again. Yeah, books, ID. Really, yes. Okay, finally, I got rid of all my typos and my code now works. So what I can now do is I can extract everything that is related to the API, right? Just everything up to here, up to the store, and create a new file, paste it here, and save this file as API.js, right? This is going to be my Node module. And since it is a Node module, I need to return something from it. I need to export, right? So I'll write module exports, and I'll write router. Awesome. So everything that is related to the logic is defined here. Now here, I can say const API equals require. Don't forget, if you're requiring the local file, // otherwise it will try to load the module from the Node modules. API, I can omit the extension, it will find it anyway. So API goes here, and my application becomes like significantly more readable, right? So I have the infrastructure bootstrap part here, and I have the application logic with the dummy REST service right over here. And this way, I can support my app better, and I can test my app better. Notice that this thing doesn't really... sorry, I need to really take parts of this app away. App use body parser. Yeah, this way it will be better. Yes. So now I have logic separately from the infrastructure part of the app, and I can test those modules easier, right? So this router, it is relatively easy to test it because, again, it is quite easy to mock the required methods, right? To mock the parts that are providing you the data from the REST services and build an automated test for it. In the upcoming session, we have the separate block on the testing, so I'm going to touch that as well, how to properly test the routes in Express and how to organize the Node.js testing overall. So let's just do the app is not defined. What the heck is app? It's not defined? Should work. Work. Oh yeah. I've got an error somewhere. API JS 11. There's nothing here. Really, there is nothing here. Oh yeah, I forgot to export Express. Sorry. Now this will work. I truly believe it will. Yeah. Okay, awesome. So it is working. My hobbits are returning back. My books are stored. And in just under, well, what was it? It was roughly 20 minutes with explanation and going through the code. I wrote a very basic REST service that already accepts new items and can give the details of the given item and can give you the list of the items. That's going to be enough for you to prototype something really quickly if you need to build that prototype. And notice one thing that I really love about Node.js, especially, well, no offense, but comparing to the Java world, here's my reload speed, right? I click Control S, it's restarted immediately, and with some extra effort with things like browser sync, I can also do the same idea for the browser so that the page is automatically refreshed whenever there is a client-side change. And if I have that infrastructure in place, when my both server is restarting whenever there is a server-side change and my client-side is restarting whenever there is a client-side change, I can develop really, really, really quickly. Okay, just as a summary, let's quickly go through what we did. And again, it's all in the presentation. That's the middlewares. That's the example of the app that serves the static files. And here's some basic features that we have implemented with the getting the URL parameters and query parameters and separating out the logic in the routers. Okay, so we're good on time. Actually, we finished right at the proper time. So thank you very much for joining for today's session. And as usual, the recording going to be available really, really soon. And in the next session, we'll talk about debugging. We'll talk about real-time web. We'll talk about Socket.io. We'll talk a little bit about Node.js infrastructure. So thank you very much. It was a great pleasure to work with you for the second session of webinar, and hope to see you again. Have a great day, guys. Bye.